Welcome to the classroom. Today we're talking about weathering and erosion, and what better place to do that with a little creek behind me, and we can actually see some engineering links like building a bridge across. So at this location there is a very low water level at the moment, but in the spring melt there's a lot more water flowing through here, and over time the limestone bedrock has been slowly weathered away. We're going to go have a look at some different layering. And this can be connected to other rivers and streams and creeks weathering away the rock. We have fine sediment in the water. It's abrading slowly at the rock. But also in the wintertime, we get freeze-thaw. We get ice built up in cracks, breaking off pieces of rock as it expands. And also when the water melts, it can take away pieces of rock because it can allow it to slide more easily. I had the opportunity to go to the Gobi Desert. And in the Gobi Desert, you get a lot of abrasion of sand particles in the air, dust storms. And it's so powerful that it can sculpt and shape even granite rock outcrops, which I was lucky enough to go see. Its impact of just that wind abrasion, but also thermal exfoliation. All right, heating up the rock surface and cooling it down at night. And you can get, 20, 30 degree differences between night and day. And that means the rock is thermally expanding and contracting on a daily basis. All right. And that means that eventually, if there are small cracks and flaws, those can grow. And you'll see examples from the Gobi Desert, very thin sheets slowly peeling off of the granite hills there. And then the wind and the abrasion can slowly sculpt and shape and peel off those layers. So there's a lot of forces at play, breaking down the rock and slowly making sediment. And the next Welcome to the Classroom video, we're going to look at deposition and the formation of sedimentary rocks. But before we do that, let's go have a look here at what's happening in terms of erosion in this creek bed. All right, you can see the creek going down. There's a couple of levels here. The limestone, here you can see that limestone outcrop. The beds are almost horizontal, I would say. I haven't measured it, but they look pretty horizontal. And you can see a bedding plane weakness here has been exploited to erode. You can see a little step under. So perhaps we have a bit of shale. These layers here, lots of bedding horizontal layers there. There's a bit of shale mixed in with the limestone. And that can create a place where we get swelling and shrinkage happening. As it gets wet, it swells, so it'll expand a little bit, and as it dries out, now that it's not wet, it'll shrink a little bit. And that repeated action, just like the thermal exfoliation, expanding and contracting, starts to drive the crack further along and deeper into the rock. And as the water comes in, it can remove material. And you can see we have different levels, okay? And these are like levees in a way, just like we might get in a stream where we get deposition. We can get levels, but that's from erosion in this case. So it's cutting down to the next level, all right? And where the dog is at the further level down. You can see right here in front, actually, a block that has fallen off. And that's part of the engineering link, in fact. So what they've done with the bridge is they put the piers onto this ledge here, okay? And it's just a walking bridge, so it's not carrying too much weight at any given time. And those blocks are probably stable enough for that kind of weight. But if we were designing a car bridge or a rail bridge to go across here, we'd have to understand how stable are the blocks of limestone there. We might want to think about the water, and we might want to anchor the bridge on something more stable if it's going to carry more weight. So there's a lot of factors here to consider in terms of engineering, and the erosion is one of those factors. How long does it take to erode back and destabilize some of these blocks? And the erosion itself, to sort of round the rock, takes a really long time. But actually freeing a block of rock like this will take a lot less time. All right, you've got swelling and shrinking, maybe freeze-thaw, and abrasion can erode it out, and you can get blocks of rock falling on a regular basis. So that's part of the engineering link. We got to consider the river or the creek or the stream at different stages of the season. There might be more water, and consider what it is we're trying to design or build across it, and how we are going to interact with the natural environment. that's the engineering link. All right, so let's take a segue over to the Gobi Desert and look at a different weathering and erosion mechanism. So as you drive along in the Gobi Desert, you see these hills really weathered, broken down, and it's almost blending into the surrounding soil. As you can see as we drive by here, the rock, it's only less than a foot perhaps below the sediment level. That shows and actually gives you an appreciation that this process is taking a long time to break down the rock because of the resistance of the granite. It's such a hard rock, a lot of quartz content. It can withstand a lot of abrasion and it can withstand thermal expansion and contraction. The weathering doesn't go too deep in this location. I think if you would add flowing water, then we'll be able to remove a lot more material and transport it away. There's very little rain in a desert environment to remove sediment. So the wind can only take the smallest fraction of the particles away. These hills have been just slowly sculpted with time. Beautiful place, very interesting, and I've never been to such a place before, so it's really inspiring and eye-opening to see such weathering and erosion happening on a granitic rock. All right, so we're back here at the creek near Ottawa, Ontario, and as we saw in the Gobi Desert, the driving force is different, but the end product is the same, a movement of the rock slowly expanding and contracting with time, and that can break down the rock.